Alright, so let's send this first one out to Micah, and the second one we're going to go to Josh Lim. Okay, so Micah, how did you start out number 9?
You start by using the quotient property.
Awesome. Tell me how to write it out using the quotient property.
Ln x squared and minus ln cubed.
Great.
And then you use the power property with the exponent in the front. You have 2 ln x minus ln.
Awesome. Now, if we use the power property, Micah, what do you got to do? You want to hear it?
What?
Oh, I've got the power?
Got the power.
There you go. Okay, this is what it would look like. Good job. Do you have any questions? Does that match what you guys got? Good job. All right, Josh, what about log 1,000x to the 4th? Times the x. Yep, you're right. So how would I write that?
Log 1,000 plus x.
Good job.
And then hold the power up.
Yes.
Get log 1,000 plus 4
Yep.
x.
Awesome job. Now, with the 1,000, kind of like you remember how with the 8 we simplified it. Did any of you catch that you could simplify the 1,000? What would it simplify to, guys? Awesome. So this is log of 10 to the 3rd. So could we use a property, the power property there as well? That would be 3 log 10 plus 4 log x. So nice job. Oh, what happened? I wrote it down. Oh no, now my computer's like, something's wrong. I might have to go connect it. Give me a second. That probably means we lost the Wi-Fi. Maybe we'll get it back. Hey, now, even if you did 3 log 10, you could actually simplify it one more step from there. Did any of you figure that out? Peyton, you give me a yeah. Did you figure it out? Yes, how come? Great job. So guys, last time we learned a little trick that if I have log base b of b, that just becomes 1. I'm writing and it's not showing here. It's like trying to. It's like we're trying to connect, but the Wi-Fi sucks. So let's, I might just connect this way. Let's see. Cross your fingers. Okay, cool. So what I was saying was last time we learned that if you have the base and the argument are the same, it is going to just simplify to 1 because rewrite this, b to the 1 is equal to b, right? So it will just become 1. Well, if you have a common log 10, the base is 10 and the argument is 10. So we're just going to rewrite this as 3 plus 4 log x. Oh, no, not that. Oh, rewrite the whole thing. So sometimes you can keep going and going and going. So always check if you can simplify. All right, nice job there. Do you guys have any questions on expanding logarithms? That's where you have one log and you make it into many logs. Okay. So now we're going to go on to the next one, which is going to be where we are condensing. Now, we're going to actually do something kind of silly here, but you're going to do it with me because it'll help you remember. Or it'll just be a silly thing, but we'll do it anyway, okay? So I'm going to put a song on and you're going to sing along with me. Here are the words. Down here at the bottom. Don't worry, I got you. Okay, you ready? One log. Use properties of logs and then feel alright. Hear the students sing. Hear the students saying. Use properties of logs and then feel alright. Saying, let's use properties and feel alright. Okay. Hey, who was actually singing? Was that you, Magdalene?
Yeah.
Thank you.
I only said the last one.
All right. So what we're doing with condensing logarithms, notice I have 3 logs. So now I'm going to use my properties and condense it till we get 1 log. All right. That's what we're going to do now. Okay? Let's do some practice with that. Now on this example, which properties would we have used to condense it to make it look like that? So product, because at first we're multiplying, and then quotient, because they're dividing. All right, so there we go. Okay, so now we are going to look at an example here. So here's what we're starting out with. So I've got ln of x to the 5th minus 2 ln of xy. And it says we want to write it as a single logarithm, which is fancy for 1 log. Now, I'm going to put a little side note here. When you are condensing, always use the power properties first. Okay, so let's look at this. I've got ln of x to the 5th minus 2 ln of xy. Now, when we're using the condensing, what that means when I say use a power property first, that means if you have coefficients, then you want to make that become your power. So do we have any coefficients written out there? What is it? The 2. So the 2 is actually going to come up to here, okay? So this is, we're going to first start off by using the power property. Someone might think the power property, we bring in the 5 down. That's when we are expanding. When we're condensing, we're putting it back up, okay? So we're going to write this as ln of x to the 5th minus ln of xy squared. Awesome. Which property are we going to use next since they're subtracting? The quotient property, which the quotient property, we're going to write it as dividing. So this is ln of x to the 5th. And down here we have xy squared. Okay, are you okay with that so far? From here it's just simplifying. If I have the quantity of xy squared, what does that mean if I were to distribute that squared? What would it look like? X squared, y squared, right? Well, now that I've done that, what can I do, guys? Can we simplify that at all? How many x's do I have in top? How many in the bottom? Can we simplify those? What's 5 minus 2? Alright, so how many x's are left up top? X cubed over y squared. So that would be our simplified single logarithm. So always see if you could simplify. Sometimes you can, sometimes you can't. And there you go. There's your first example of condensing logs. Any questions there? All right, let's do, when I say let's, I mean you. You guys do 21 and 22. And then I'm going to do that bottom one with you, okay? So don't do the bottom one. Just let's push the pause button here, and you guys do 21 and 22.